everybody. Welcome to our workshop for Open Robotics. So on my right here, or possibly on my left for you, is Farhang Naderi, who is the CTO and co-founder at Caretta Robotics, who's going to be giving us our workshop on Open Robotics and Open Robotics stack for underwater autonomous vehicles. And so there's going to be a presentation about Caretta Robotics and a workshop. And then after about half our time has elapsed, we're going to be joined by some other experts from really cool platforms that interact with Caretta, and we'll introduce the rest of our speakers then. But be sure to use the Q&A, which should be an option at the bottom of your screen, to drop questions in there, because there's going to be that whole extended question and answer session at the end. You can ask them anything you want, maybe within reason. But yeah, all right, take it away, Farhang.
Thank you very much for your introduction. So first of all, my voice is coming clear. I hope so, that everyone is hearing my voice clear enough. So yes, thank you. Thank you for confirmation. All right, let's jump into what I'm going to be talking about this session today. So let's say quick introduction about me. My name is Farhang. I am a co-founder and CTO of Caretta Robotics company. We are based in Cyprus, and we are doing autonomous underwater vehicle software, basically, mostly focused on that. We are a startup company. We have started like 2 years ago, and now I will briefly tell you what's going on in our company and at which stage we are. And for sure, we have started with open source solutions. And I will also let you know at the second half of, let's say, my session, how you as a developer, if you are interested to jump into underwater vehicle development, where you can start, or where are the starting points for you. Okay, let me share my screen. All right. We are as a let's say first decision we had for our company was that we wanted to try to use open source solutions and, let's say, best customizable solutions. So we went for Blue Robotics Blue Rov 2 heavy kit according to our need. For now, as I told you, what we are doing, we are working on autonomous vehicles for underwater purposes, and basically focused on environment, let's say, monitoring and inspection. On my backside, you can see our vehicle, by the way. What we are actually doing at the moment is that we are doing autonomous environment surveillance based on autonomous missions for debris or solution and a specific use cases inspection, let's say shipwrecks inspection and other similar things. Also, we can provide marine environment data like specific temperature, let's say water flows underwater at specific, let's say, locations, bathymetry maps within like 1 meter of error rate, and we can also do tracking and following objects underwater. These are the whole things we have achieved already. What we have done, let's say, so far pushed to the current available solutions. We have brought a Nortec DVL device as a sensor for our localization underwater, and implemented on our Blue Rov 2 vehicle. And we have also implemented autonomous missions using Mav SDK and Roche, which I would be talking about them if we have time. We have done fail-safe implementations that are tested, let's say, in practice for underwater vehicle, and we have also our vision processing and object following and tracking. And in addition, by using our ecosounder data and DVL data, we can offer bathymetry maps. We have won some, let's say, bi-communal events in Cyprus. I participated in Young Entrepreneurs event in Dubai. In Turkey, we have participated in another tech event last year. We have participated in a slush event in Finland. Locally, we have gone for inspection from, let's say, oil spill, which was happening last year from, let's say, Eastern Mediterranean. And also we have done some underwater, let's say, inspection tasks that are based on our vision, our vision processing system that we have developed. So this is the current, AI module that Caretta Robotics have developed. We have brought the hardware, which has, customized hardware for us, like our embedded controller, AI module, sensors, and cameras, in addition to our specific algorithms. And as a combination, we can offer those services I mentioned you, like obstacle avoidance, species direction, and hazard detection, and any services mostly for underwater inspection, which is based on what customers are asking. So this is our vehicle. Basically, this is Blue Rove 2 Heavy. If you search for it, we have added that bottom enclosure to it. That is IP camera and edge machine learning device. And everything is connected through the network. We are not using anything serial except the camera on top, and everything, even camera on downside, everything is based on network, operating based on IP and networks, and like TCP and UDP algorithms. So this is our one service, like bathymetry, that we can offer. For now, the software has been developed by us, although there are many solutions out there. And here you can see the comparison between edge device detection on left side and the algorithm we have implemented with an accelerator and edge device that we are also registering a patent for it. And you can compare the performance already. By the way, this whole thing is being done on the device itself. And here you can see that we are able to do like pipeline inspection, oil and gas, and any kind of underwater inspection. We have used OpenCV for this, so that we can track a specific line, like pipeline, and we can give data for any artifacts through this whole channel. And also you can see 2D mapping here, which we are capable of using autonomous missions, since we have underwater positioning system from our DVL device acquired. And yes, these are all about Caretta Robotics and what we have achieved so far. In the future, we are planning to do multiple vehicles, up to 200 vehicles, which could be, controlled on a specific station, and they could be doing like a swarm mission together. So let's see what you will be needing if you are going to jump into underwater development in simulation. For sure, what I told you, what we have done already, they are all on hardware, but you know that underwater, market is a bit expensive market, so maybe not all are intended to jump into having a hardware and development directly on hardware, unless it has been proven on software and simulation. So far, we have some solutions developed already very well, which they are open source and you can get benefit from. I will go over, although there might be many, but I will go over what is available for now and what is, stable for now. ArduSub is a part of ArduPilot project, and they are offering simulation environment, which is stable for now. You can use it for, for underwater vehicle. It exactly has the simulation of Blue Rove 2 kit. And also on PX4 AutoPilot side, you can also use simulation for that from that side as well, but it is experimental. The good thing about PX4 is that it gives you ability to communicate like using ROS 2 with RTPS and FastDDS, middleware. But if you're using ArduSub for now, you can use ROS and MavROS, which is quite fine for practical, solutions. And also Project Dave, which is another project going on with, ROS community, that you can benefit from many sensors and actuators. You can have customized vehicles, and you can have, let's say, a bunch of different topics to access to. I mean, those topics you can access to and you can benefit from and like customize and edit. Okay. What you would be needing. Let me jump into directly jump into what you would be needing. So you can go over and research for many of them, but basically, preferably, you will need OpenOS, you will need PX for Autopilot development environment, Autopilot development environment in case you want to use either of them and compare. Ground control, which is from, let's say, Dronecode side, is a project of Dronecode that you can use for your mission plannings and see and control your vehicles. Basically, you can have your video feeds also on that. And ROS with MavROS packages installed and OpenCV package and a bit of prior knowledge of customized builds for, let's say, ARM processors and STEAM processors in case you want to jump in like deeply and change the builds yourself. Otherwise, most of this stuff could be done with by using Mavlink and using Python Mavlink, and you can have your own codes and implement them. All right, I will jump into what we have here. I will start with Autopilot first. So first of all, let me tell you where you can get this data. If this guy goes up. Here, if you go into ArduSub website and under developer side, you can see that here you have this running ArduSub CTL. But before that, you have to have your CTL environment settled down on Autopilot, which you can go over it and like have your, let's say, setting up CTL here, and you can have it according to your let's say, environment, which I prefer and I recommend Linux with it. Then after that, everything, if it's ready for you and running, you can start testing. Okay, what is happening here? Let's jump into that. I have let's say, a specific script here, which will be running the simulation environment for me. I will and here, what example they have given is your, let's say, Mavlink communication, UDP port that you are passing through. But since here I'm going to be using ROS, so I will not be passing that. I will let you know why. So here I am running my simulation, and you can see here I have my terminal showing exactly that my vehicle is, let's say, launched, and my GPS is fused and IMU is fused. This is how Autopilot basically is communicating with you. So if you have a real vehicle, you will also see these, but there is a big difference here. Don't forget that on this simulation, we have GPS being fused, but underwater, there are no GPS existing. So you have to have other replaced solutions like using DVL, using other underwater, let's say, localization solutions so that you could feed something like GPS underwater. So this is only on simulation that everything is going good and you have GPS, let's say, here attached, but in real life, in practice, this is not the case. So you have to come, let's say, come over those limitations later. But anyway, we just want to get the idea what's going on here. The next, what I would be needing, I have here. Okay, and here I have, yes. I have already installed MavROS. MavROS is a package from ROS, which you can be controlling, let's say, drones and underwater vehicles. It is giving you a, let's say, huge capabilities for specific topics accordingly that you can control your vehicle and services as well. It is consistent enough and it is settled down like very well that you can use for your vehicles to control your vehicle. So documentation for that is available. I don't have time to go for that. I'm just giving you the keywords. I will be running my Mavros here. You can see that my vehicle is connected. And my FCU here, which is flight controller unit, has been detected as autopilot, and RC channels detected everything, and mission received. I have one terminal here on Roche side. And here I will run my ground control as I told you. All right. Here, if I can make this guy big. Yes. So here I have some controls, let's say, over my vehicle. I can like change the modes here. I can have like arm, disarm vehicle. So let's say having a small mission here. I will make this like second point and then to here. And then if I have my altitude for takeoff, which we have to go underneath, it will be 2 meters. Okay, and then the next waypoint is also 2 meters. Okay, I can pass them, I can upload them, come to fly, and then I am going into auto mode, and you can see that my vehicle is going down. This screen is a bit, maybe like this is better. Okay. So I have passed like -2 meters. So according to the end of waypoint, we have to be reaching there underneath. You can have full control. And meanwhile here, an analyze tool, you can have your all, let's say, Mavlink messages. What Mavlink is, you might search it for yourself later. But Mavlink is a, let's say, Mavlink is a protocol to communicate between your vehicle and your ground station, basically. And these are all the messages that you are receiving, like your pressure, like how motors PWM are being done, like how RC channels are going, which you could be familiar with them when you go through the documentation. So this is a simple mission that we have implemented. And on the other side, if I have my, let's say, ROS topic list here, you can see that on Mavros, I can have all the topics which I could be like subscribing to or publishing anything I want. This is always like not all of them working as you're expecting, but you need some, let's say, research on those, how you could be benefiting from them. All right. What else I wanted to, one more thing. Here I will be for sanity check for OpenCV side to say that we can also use that. I am feeding a fake testing video, and I am feeding this to my UDP port 5600, which here in my QGC I have as here as my UDP port, and I have a script. Where was it? Yes, here. I have a script here. Let me see if I can see it. Yes, I can have this OpenCV, let's say, frame received here. Also, since it is, let's say, UDP port, I think QGC has to also take that. Yes, QGC is also taking the same frame here. All right. One more thing I wanted to say was, okay, I think I am okay for that. I think I don't have time for going through Gazebo because our time is going to be limited a bit. Okay, that is all on my side. Let me just let you know what is going on. Yes, by the way, there is another, if for the ones who are going to be looking into Gazebo with Ross, Patrick has this Blue Rover Ross Playground on GitHub, which you can follow up, and you can have Gazebo running. And in this simulated environment, you can run your, let's say, your own vehicle here, and you can have like the same way I did. You can have Mavros running, and you can have your Gazebo as well running on here. All right, thank you very much for listening. and I hope I have covered like everything I was planning to, although Gazebo is missing because we have lack of time. I wasn't able to run it. So meanwhile, if we jump into Q&A session, maybe I could be able to run that as well. Thank you, everyone. If you have any questions, or we can jump into the next part.
I think that we're good to jump into the Q&A. All right.
Mm-hmm.
Well, exciting. Thank you so much for that demo and workshop. I'm going to introduce the rest of our panelists now, and everyone remember that you can drop questions in the Q&A. There's already people posting some interesting stuff in there. I'm really excited to see what you have to say about that. But yeah, so our panel is going to be Farhang continuing, and Kat Scott, the developer advocate at Open Robotics. We have Ramon Roche, the general manager. Oh, there's some crosstalk happening, but here we go. Ramon Roche, the general manager at the Dronecode Foundation. We have Phil Nelson, the director of content and creative at OpenCV. We have Ian Galloway, who is a mobile robotics team lead at NXP Semiconductor, and my colleague Ginger Zhang, who is the contest manager at Hackster, and also our team's resident drone nerd. Welcome, everybody.
Yeah, great job, Farhang. It was a locker room sellout, as they say.
Yeah, gracias, Alex. Hi, everyone. How's it going?
Hi,
hey,
everyone.
Can you all see our faces in here?
Hey, good morning, everybody.
Yeah, we already have good questions on the chat. Thank you.
Oh, this question has been my burning question all week.
Yeah.
Oh my God.
Can I read it out loud and you do the answer?
Yeah.
Question to the panel. When pushing the limits with robotics and as products that have potential military applications emerge, how difficult is it mitigating influences and interferences from nation states, military organizations, espionage agencies, etc.?
It's a question we've been trying to answer this week. So I don't know if you've seen it, but I think, what was it?
I'll go ahead and grab the link for you.
Yeah, it was Thursday, I think it came out. So Boston Dynamics, Open Robotics, and a number of other robotics companies basically signed a pledge that they're not going to weaponize robots. And there needs to be a clear distinction between weaponization and military use. And weaponization is specifically attaching arms to robotics platforms, or robotic platforms. People have varying degrees of definition of military support. So some people say, not even once, no, nothing, don't allow the military to use any of these technologies. And then certain people are more in favor of, well, do not weaponize these technologies, i.e. don't allow them to be armed. So having said that, make that distinction clear, as it stands right now, the only thing you can do is, you can withhold your labor and your interest in these projects, which I think a number of companies have already said. And depending on the licensing arrangement and such, and how things are sold, you can do more or less to enforce that. So having said that, there's no really super satisfying answer as into how to prevent it. And I think, at least coming from my perspective as somebody who helped out in that whole weaponization pledge, it really was an ask for help. It really is saying, hey, this is something that's on the horizon that we don't think should exist. We're not going to participate in it. In the sense that we're not going to build these things for people. We are going to build them, but we are not going to build them for these people. And if they purchase them and do stuff, sometimes we can do things, sometimes we can't. Having said that, I think, the reason that letter happened is people need to understand that this is happening now and that there needs to be some sort of actual legislative or social pushback to prevent it.
You had an awesome point already, which is, the best thing to do is just don't work on it. Mm-hmm. Like, they need you a lot more than you need them. Just don't work on it.
Yeah, and the dual use thing is really important, because I do think that, legged robots do have actual useful applications. I think, USVs, or underwater vehicles, have like amazing science applications. Drones have amazing science applications and other applications. And it's this dual use thing. We want to build these things. We just don't want to build them to do not cool things.
Well, and as more and more of the U.S. becomes underwater, this will probably become a lot more important even.
Yeah, so definitely, I want to bring this conversation more towards, like a positive spin. This is our Impact Summit, and we have a amazing lineup on talking about what sustainability, what's impact, what tech for good, not all means, to different organizations and companies. So, and maybe just for those in the audience who's not super familiar with this this panel here, we can Farhan already introduced his company. Kat, maybe we can each go through a little introduction of each of our organization, and what's new and how it all fits within the open robotics stack.
Sweet.
And I think
I'll go first. You want me to go first?
Yeah, Kat.
Okay, so I work for an organization called Open Robotics, and so we are sort of the organization that maintains Roche and ROS2, Gazebo. We have a new one called OpenRMF, which stands for Open Robot Middleware Framework. It's basically there to control multiple fleets of robots. And so we produce a lot of the open source code. We can help customers build features, open source features for Roche. Sometimes we also help them kind of get set up with their projects or do like preliminary design reviews. That's sort of our bread and butter.
Yeah,
Ramon,
somebody else go next. I'll go. I'm Phil Nelson. I am the Director of Content and Creative at OpenCV. OpenCV is the biggest computer vision library in the world. It's been around for about 20 years. We do all sorts of stuff with competitions for people that are just learning computer vision, artificial intelligence, and our software fits into this sort of autonomous vehicle stuff by pretty much everybody uses OpenCV for something at this point if you're making a computer see something.
Awesome. Am I next?
Yes, Ramon, you're next.
All right. Well, thank you, Ginger, for inviting us. And thank you, Alex, for the intro, and all of the Hackster team for allowing us to be here and giving us the space. My name is Ramon Roche. I'm the General Manager for Dronecode Foundation. Dronecode Foundation hosts the PX4 autopilot open source software and a few other open source projects for drones. We've been working in the drone industry for the last decade and pushing for more adoption of open robotics in the robotics industry in general. We focus more specifically in flying robots, but we also have support for rovers and underwater vehicles like Farhang was talking about. Farhang is one of our top contributors in the open source ecosystem. And I think that's a great intro for us. Happy to discuss drones in more length with you.
Awesome. And we actually have a special adding guest today, Ian from NXP. Hi, Ian.
Hi, everyone. So I'm with NXP Semiconductor, and we're kind of a little bit lower down on the food chain. We make chips. We're one of the large semiconductor vendors in the world. Most of our chips go to automotive, industrial, medical uses. And I'm part of a mobile robotics team inside of NXP, and we've been very much focused on supporting open source and bringing things from, say, we generally would make a chip and then a development board for evaluating that chip. But for example, behind me is a picture of what we're calling NavQ Plus, which is a purpose, acting more like an end customer, building something with interfaces on it that are suitable for mobile vehicles, like, dual CAN buses, dual Ethernet, dual cameras, a neural net accelerator running. And, we do the work to make sure it's running the latest Ubuntu, the latest ROS2, the latest OpenCV, EIQ software to do neural nets and that sort of things. And then running open source, open competitions in cooperation with Hackster here, such as our Hover Games 3. And we have that program starting very shortly. So this type of board, which is sort of your industrial or automotive equivalent of a Raspberry Pi, let's say, and then all sorts of other building block pieces like CAN nodes, 2-wire automotive Ethernet, stuff that just hasn't been seen before in this world, that we're bringing all this higher end equipment down to the mass market. So
Awesome. So we have a really good question from the audience already. Says, I along my friends have been attempting to make an AUV for an upcoming competition. How do you think we should approach it should be? Are we currently using just a nano for running OpenCV modules locally? Kindly comment on how we can improve more on it or any alternative of sorts. So we definitely, have our hardware NXP folks here, and we have our software, like from Phil, from CAD here, and this is a panel to ask the question, what is your recommended tech stack? And in terms of all the different open source tools, how do developers actually the best way to save their R&D energy in hardware and software selections?
Yeah, I would say right off the bat, maybe try the Hover Games kit. Maybe try to see if the challenge, maybe you want to participate in that. It has everything you need to build a drone. Like Ian was saying, you get the frame, you get the flight controller, and it's just amazing to get a first development kit going, and you can augment on that. You can keep building on that. So it's a great way to get started with open robotics in the field.
Well, I'll interject here. We get this question a lot, and it's a difficult question, right? Because at the end of the day, no one knows your application as well as you do. And people are like, well, what is the best for me? And it's like, well, I don't know what you do. And really that is part of the job, is figuring out the best thing. The sage old advice I've always heard is optimize last. So probably over spec and then work your way down is a good approach. But at the end of the day, you're going to have to back of the envelope what your requirements are and specify your hardware from your requirements. That's sort of part of the job.
Yeah, just echoing what Kat said, safety third, optimize last.
It is, yeah, Kat's right. I mean, for example, this processor is great for what we consider the average light industrial type application, but we have many other parts that are used for real avionics. They're DO 178 certified, and you're not going to fly a large vehicle with a small board that's not gone through certification or has functional safety.
So actually, I have a question, kind of like of my own, in terms of like when developers, especially when they're dealing like with robotics and hardware and software. Farhang didn't get to the Gazebo part of the tech demo, but simulation is actually a very recommended process, before you get into hardware. Some developers, would do hardware first, and I actually, very similar to Farhang, and do kind of like the simulation environment first, and maybe, but I then later find out that's not always an approach that a lot of developers take. So could we talk a little bit more about that, and how do people even go about it, Kat?
So, sorry, go ahead, Kat.
Well, so simulation, right, I've said the biggest mistake I think I've ever made is not building a simulation before I build a robot. And the reason is that you're going to, everyone thinks, oh, working on robots is so much cool and so much fun, until you're on the floor at 2 a.m. trying to figure out if something is unplugged or your code doesn't work. And so basically building a simulation allows you to eliminate an entire class of error, which is called hardware, and sort of see what different configurations are going to get you ahead of time. So the process is lengthy, right? Because to do a good simulation, you have to have a good model, which means you have to have a good estimate of what your thing's going to look like. I think probably the most recent good example we have is we just released the Turtlebot 4, and as part of that, one of my requirements was to make a complete Turtlebot 4 simulation that's just free and open source. And so you can take a look at how we did that, how that runs, basically go and take your robot, do all the things that you would do with it, do all your software development, which is huge, right? You don't want to write code on the floor with your robot and test it there. You really want the simulation to be there so you can work at your desk, get everything done. So I think the Turtlebot 4 is kind of a decent model to hold up and say, here's a good approach to doing simulation in robotics. I'll toss a link here in the chat real quick.
Also, a lot less blood loss by volume for the simulation versus real life robots.
We learned this with we have a program called NXP Cup, and it's involved with racing cars around a track, and you know, without simulation, they go smashing into the wall at some point, right? Somebody does something wrong, there's code that goes awry. So we built up the simulation environment for the Buggy 3 car reference design that we have. And then after that, we also built a full model for our drone, the Buggy, and another product called El Mandadero that's a large robot reference design, not fully launched yet. And publish them. You know, the important thing is to get it out there. So it's published in an Ignition Gazebo in the fuel store, basic. So it's click and connect. And then we try to do other things like plug and play for the Create 3, the Turtlebot 4 platform. So, you know, with one USB connection, this board's up and running with a Create 3. The challenge is you can't buy this board yet. The only way to get it is through the Hover Games 3 at the moment. But the difference, or one thing that we also found that was really useful is not just, so pure simulation's great in Ignition Gazebo, but then doing hardware in the loop simulation is also super helpful, because then you start learning the constraints of actual real physical hardware. Because, you know, it's one thing if not everybody's got an Intel laptop sitting inside their robot, and you maybe don't want that. So when you start getting constrained, or you get interactions on different communication buses and things like that, having real hardware looped in, connected to the simulation is really quite helpful.
Awesome. And Kat has thrown in some resources links there. We'll also share with, you know, the audience some other resources from all these amazing open source organizations where you can find that path. And Ian, for this year's Hover Games, we actually have a sustainability award.
Yeah, that's right. So our Hover Games 3 is land, sky, and food supply. And we encourage people to use drones or rovers to, in some way, support, you know, farming or sustainability. It's those we're you know, not constraining it too deeply, but it could be, I don't know. I hate actually defining what it would be, but something like, you know, with livestock, it could be pollinating trees, it could be something with fish farming, it could be just delivering a soil test kit, or all kinds of other really interesting ideas. But the sustainability award is part of that, and there's quite a few different ones there. Yeah.
Awesome. Yeah, and Farhang, like you have, you know, this amazing panel here, you know, as a kind of a startup doing, you know, underwater ROVs or any what sort of like other robotics challenge that, you know, from the technical perspective you faced or you want to discuss here?
In our company or overall?
Yeah, or, you know, in general.
Okay. The first thing which is related to this discussion now is when you are switching from simulation to action. That's for those who want to go for, let's say, MVPs, and after that prototype, this interaction. So you have your software, let's say, ready and everything ready, then you come to hardware side, then you think that everything collapses. So and in action it is also like that. So what we faced, like, as a simple thing that I mentioned during this panel, I tried to even emphasize on that guys, your underwater vehicle in simulation here has GPS, but in action it doesn't. So as a developer, you go in the field, you have your vehicle, and you're like, okay, nothing happening. So yes, this shifting is the first challenge that you are facing, because in hardware, many things changes and like new challenges are coming up. So it is like you have to choose where your aspect is, like where you want to be standing. You're only software developer, or no, you are going to be contributing to from software to something which can move.
So I have a question. How do you get a failed autonomous underwater robot back out of the water? What's the standard operating procedure for, one of these guys is like, help me. What do you do?
Yes, what we have is that it comes to the surface itself, and we have to go for rescue. No other way.
like a dead man's float, kind of.
Yes, for example, because normally our buoyancy is positive, so and as we are going more down, it is more. By the way, we have tested up to 300 meters for now. So when it is like our data link is disconnected, or let's say we have leakage or this stuff, it instantly disarms and comes to the surface. So we can just spot them, and at night we have a specific LEDs, indicators, different colors. They could be spotted.
I'm wondering when we'll get to the point where there will be autonomous underwater vehicle rescuers that are also autonomous.
Yes, that would be also possible. It is soon it will be on the plan. No problem. But yes.
We actually had a really interesting question from in the other session yesterday, asking, because they are making these IoT devices that float in the ocean buoys. The question was, what happens if a whale swallows a robot?
Call Ahab.
Right. Would that actually ever happen?
Hard form, maybe.
Did that actually ever happen? And Farhang, how many of these have you deployed actually in the so far in the world?
For now, our vehicle is only one, because we are. Our hardware side is finished. It's been 6 months, and for now we are working on software distribution. So we are mostly focusing on packaging and distributing software. So the vehicle side, we finished with one because we needed an MVP, and we were in a, let's say, agility was the case. So yes, but in the future, we're planning to extend them up to 100, 200. QGC can take up to 255, so we can push to that.
Abraham, I have a question.
Oh, I was going to say, though, sorry, Ginger, your comment about the underwater sensors and things in the IoT, it's quite interesting because I get asked a lot from oceanographic institutes and things like that. They're quite interested in moving from sort of bespoke IoT solutions to just adopting the same robotic infrastructure that we have, even though an ocean-going buoy is not a robot per se, but it does communicate. It's got sensors, it's got networking and storage and all that's things we do already in robotics.
There is, well, not in sort of maritime robotics, but definitely in space robotics, there's now a big push going to have a unified sort of framework for building space applications. I think we'll probably see that a lot in the maritime space. The thing that I keep bumping up against, and I've been trying to push people to work on more, is usually when you're doing maritime applications, you're integrating satellite data and geospatial data and live streams from the robot and all this stuff. And we could do all these things in Gazebo, but they're not quite all the way there yet. And I think, there's a lot of space if somebody wanted to come in and start being if you want a sweet job, go start being the person who can take bathymetry data, satellite data, live robot streams, and historical data, and integrate it all into a 3D display so that people who are doing science can make sense of it.
Yeah, sensor kit bashing is the next gold rush, perhaps.
Yeah. Well, awesome. I think, we're out of time. This panel is really short, but I really appreciate, everybody here to join this panel and have this discussion. It's actually really hard to get everybody together, from the hardware and the software side. For those of you who are interested in chatting more, please join our Discord. And, you know, some of our panelists, you know, might be hanging out there and can chat with you more. And also we will send out information how to follow all these organizations and join, or you can join Hover Games. This is kind of like our open robotics friends, and really happy for you to all be here today. And thank you so much for joining this session. And thank you for all the panelists for your time today.
Yeah, thank you so much. Thanks so much to all the organizers here. This is so much work to put on. So thanks.
Yeah.
Yeah. Congratulations, everyone.
Thank you
We're
very
doing
much.
it in 2 weeks for ROSCON. Oh, ROSCON live stream is free. Please watch it.
Yeah. Go to Japan, yeah, go to Japan if you can still get it. Yeah. All right. Well, we'll send out more resource information to everybody who's interested in the robotics stack, you know, in the audience. And thank you so much for joining.
Thanks so much.
Thank you very much.
Thank you.
Bye.